Hey, what's up, everybody? This is Mr. Love here. We're going to go over a problem that deals with Snell's law, the angle of incidence into a material and how that angle changes as the as the light ray moves through the material. Excuse me. Okay, so we start off with Snell's law, and that's where we got to begin. So if we look at that. The law says that n1 sine theta 1 equals n2 sine theta 2. Okay, so there's actually 4 variables in there. We need to find 3 in order to be able to solve that algebraically. The problem reads that a ray of monochromatic light passes from air to lucite, an angle of incidence of 30 degrees. Calculate the angle of refraction. So really, one of the more important parts of the information that's given is this 30 degrees here, which is shown on this diagram. The monochromatic part is only important so far as that our indices of refraction are based on light that's that similar frequency. So from this chart, we look up the indices of refraction, and we see that air has an index of refraction of 1, and lucite, which is right here, has an index of refraction 1.5. Okay, 1.5. And so we can start making some substitutions. Also, what's shown here is that this theta 1 equals 30 degrees. So now is the time to start making substitutions. So n1 is 1, so it's 1 times the sine of 30 degrees equals n2, which is that 1.5, times the sine of theta 2. Okay, and so this is what we're looking for, the sine of theta 2. The first step is to figure out what this sine is. So 1 times the sine of 30 is simply the sine of 30. The sine of 30 is 0.5. Okay, 0.5 equals 1.5 times the sine of theta 2. You have to bring this 1.5 over to the other side, so you divide that by 1.5. Divide this by 1.5. And you get 0.333 when you divide this number. 0.333 is equal to the sine of theta 2. Okay, and on your calculators, you have to use the inverse function of sine to find this. So what it looks like is this: sine to the negative 1 of 0.333 equals theta 2. And when you do that calculation, you get 19.5 degrees equals theta 2. Okay, so what this is saying is that when the light ray enters lucite from air at an angle of 30 degrees from the normal, it continues onward. Let's get a little line here. It continues onward at a different angle once it enters, and it looks something like that. And this angle here is theta 2, which is what we just solved for, and that is 19.5 degrees. Okay, the main issue that I think people have been having with this type of problem is actually fighting with the calculator. making sure that one of the first things is making sure that your calculator is actually in degrees, because we're doing the calculation in degrees. So when you, if you have this TI-84, which everybody has, if you hit the mode button and you look at it, which might be hard to see, you see a screen that looks similar to that. You have to make sure that your calculator is set to degrees, if you have it previously set to radians. Otherwise your calculations will come out all messed up, and you definitely don't want that to happen. And also, just be careful doing the algebraic rearrangements. My recommendation is, when you work through this problem, even though I showed how all of these calculations this flows, I would try to punch these numbers into your calculator to make sure that you're getting similar responses out of your calculator. Otherwise, you're going to struggle with it when the time comes to actually perform the calculation. Okay, so you got to make sure that in addition to understanding how this problem goes, you have to make sure that you know how to use your calculator. Because if you don't, you're definitely going to struggle with it. That was part A. Part B simply is using a protractor and a straight edge in the following diagram. Draw that refracted ray. I didn't necessarily use a protractor to draw this. You just saw me draw it. So you have to be careful. You got to make sure that you line up your protractor such that that horizontal axis of the protractor is up along this normal. And when you measure that ray out, it should look something similar to that. So that's it for this one. If you have any questions, just email me. Thanks a lot.